Hi everybody, this is Mrs. Ellsworth. We talked about generating electricity. In fact, we even generated it ourselves. We used our hand generator to help light up a light bulb. This guy right here, he's thinking about, how do I light up that light bulb? Anyway, so we went and attached the two alligator clips on several different types of devices. We had a light bulb in a base. We had some Christmas bulbs that were cut up, and then also one that was a blinking bulb. And also we would take the light bulb out of the base, and also we used a piece of steel wool. So you had this type of situation, and so we had some major questions that we need to think about, and I also posted a document online that is what is the big picture, and so you should be answering those questions as soon as possible. But what makes the bulb blink off and on? If you go and you look carefully inside of that blinking bulb, that Christmas light, there is a plate in there, and then there's a gap to the next piece of wire. So what do you think is occurring in that situation? So it's building up charge, and this going in is jumping to the wire because it's got so much charge it can do that. And that attraction helps it jump from one to the next, and that's when the bulb lights up, and then it shuts off when it's done jumping, and then the electrons have to build up again, and it's just a repeated cycle over and over. So that's one way of looking at that. Another one, why do you think that we use steel wool? What could this be an analogy of? Well, those are very, very thin wires. And inside of our bulbs also there is very thin wires too, but those are usually made out of tungsten. It's a different kind of element than steel. And you could tell that steel obviously would catch on fire because we would overload it. Okay, and that was easy to do, and it would catch on fire, or else it would turn into ash, and you could see it glow, and that was pretty exciting. If it was inside of your home and you had larger wires that were overloaded like that, that would not be very exciting. That would be scary. And so that's what we were trying to show about that, was how you can overload a circuit with this really, really fine steel wool. Okay, what did it take to get the bulb to work without a base? That's what we're going to be discussing next. So I'm not going to answer that one right now, and hopefully you can answer that one, because you guys had to work on that for a little bit to get that. But let's go ahead and get started on the next part of the notes. Okay, electric circuit. You create an electric circuit. You created a closed one. As soon as it's closed, then your light bulb would light up. Okay, and so the electricity appeared to go from the generator to the light bulb, and then back to the generator again. We call that a closed loop, or else a circuit, and it goes like a circle. So let's go ahead and give this some information here. So this is a route at which the electrons can flow, and so it goes away from the generator and comes back to it through both of the two different alligator clips that we have there. And so here's a picture that came along with our book that describes how it will go through the bulb, and then come right back to the generator. Okay, so how did the energy chain forms? Okay, we could discuss electromagnetic energy, electrical energy, mechanical energy, chemical energy, and thermal energy. So, how can this change to different forms? Well, you have mechanical energy inside of you. Anything that has moving parts to it is mechanical energy. But there's even an energy that occurs even before then. Where do you get your energy? Think about that. Okay, where do you get your energy? Anyway, so then you crank this, and then that goes and transforms mechanical energy into electrical energy. Then the electrical energy flows through the wire, and then it comes and it lights up the bulb. Now it's had another it's transformed into a different kind of energy again, and this is light energy and probably one other energy, thermal energy. Okay, there will be some heat involved in that. Always got wasted heat in almost everything. Okay, and then it's going to go and some of the electricity just flows through there, and it slows down through resistance, or friction. Okay, and then it lights that up so it converts, but still you've got energy that's still flowing back as electrical energy back to the generator. Okay, and that's saying pretty much everything I just said. Now, this right here is a small generator. It's a small hand generator. It doesn't produce very many volts or amps. And so when we've got to heat up the world or light up the world, what do? We have cities, we have small communities that need more energy than this. And so we have to have these large turbines. They make a lot of energy. And they can, what generally gets them to go cranking on them? Well, is steam, or wind, or hydroelectric, or it could be heat from either oil or coal or gas or uranium fission. Those type of things are what helps get the turbines moving to create that electric energy. So it is actually like creating this right here would be like a turbine creating that electrical energy going through there. Okay, so I'm going to ask the class to tell me about their 8th grade trip. They saw some of the wind turbines up there, so that'd be interesting to hear some of their take on that, because of course I've never gotten to see that like you guys did. Okay, so then how does a light bulb work? If you didn't get to this part of the lab, this is a huge hint. Notice that it's showing something coming from the bottom. Okay, so it's got an electrical conductor right here that goes to the wire. Okay, this tungsten little spring of wire, and then it comes back through here and it goes out the side of the light bulb. So that might help you figure out how do you light up a light bulb if you have not been able to finish that lab. Okay, and then there's questions at the very end that you need to look at in your notes and identify which bulbs and batteries would work the best. Okay, but then I have some checking up questions here that you need to answer on your sheet, and then you can hand that in. Well, I will see you when I see you. Bye-bye.